Good evening, everybody. Thank you for joining on time. And it is the time for us to start this session. This is Bhanupriya. It gives me a great pleasure to welcome you all to this technical session. Today, we are honored to have with us an esteemed professional whose experience, passion, and dedication to software excellence are truly inspiring. Please join me in welcoming Mr. Selvam, Corporate Learning Expert at SAP Labs India Private Limited. Mr. Selvam is a certified Kubernetes application developer, cloud native enthusiast, certified master trainer, and seasoned corporate learning expert with over 20 years of rich experience in software design, architecture, and the development of cloud native applications. At SAP, he plays a pivotal role in leading skill based learning initiatives globally, focusing on crucial areas such as software engineering, DevOps, and cloud native development. His efforts are helping to shape the next generation of software professionals within the organization and beyond. Beyond his role as a learning leader, Mr. Paneer is also a passionate trainer delivering training programs across the globe, empowering SAP team with cutting edge knowledge and practical expertise in cloud native technologies. Today, he will be guiding us through software craftsman or coding principles, how we can write better code and grow as responsible and thoughtful developers. With that, let us welcome Mr. Selvam to share his insights and inspire us journey towards the software excellence. Thank you. Over to you, Mr. Selvam.
Thank you so much, Bhanupriya. I hope I'm audible.
Yes, you are audible.
Perfect. Excellent. Thank you so much, everyone. Good evening, all of you, all the students on the call. Really great to see you all. I see the number of participants, 380 plus. Really good to have you all on a Friday evening at 6 o'clock. That's really shows your commitment, passion towards learning, right? So without further ado, let me go into the topic. And Bhanupriya already introduced me. So today actually I am 18th year of my anniversary at SAP. Yeah. So I didn't realize that today morning I got a mail from our CEO that I completed 18 years. So really happy to be with you on this occasion.
Wow,
So
congratulations.
yeah, thank you so much. So I was a student like you, 22 years, 23, I think 21 years ago. Yeah. So I've been with the industry for more than 20 years now, having seen this transition of application development. And I can still remember my days when I was studying in the college. I basically did my computer science degree, Bachelor of Engineering. I don't know how many of you are from the computer science background. But I think since you joined this technical session, I believe most of you have the interest and enthusiasm about computer science, and by now yeah, many of you are from computer science. And yes, so you know how the transition has happened in the past. Now I think it's the world of generative AIs, right? So all of you, I'm sure all of you are learning about artificial intelligence, which I am also learning now, almost at the same time. I think you will have better opportunities to learn more than me, I would say, because of course I have other commitments and everything. But yeah, so the industry has evolved a lot, and I think in throughout these sessions, I think there will be many other trainers, speakers, and they will also be sharing their experience. And I can clearly tell you the approach for software development has changed, and it's more crucial that you have this the skill of software craftsmanship during this time of artificial intelligence, and not to leave everything, but definitely you should be having the upper hand when it comes to AI, right? So what I'm going to talk about is some of the fundamental principles of software coding that has not changed that has only become more relevant these days. uh, that will differentiate any developers with a craftsman, software craftsman. Yeah, do you want to be a simple just like a software developer, or you want to be a software craftsman or craftswoman? So we don't discriminate, but the term is given like that. But yeah, software craftsman or craftswoman. So you have to have certain coding principles with you, right? So we are going to quickly talk about that in the next 45 minutes. And if you have any questions, you can ask towards the end, or you can put it in the chat. I think somewhere you can capture your questions. So with that, I would like to begin my presentation. For that, I will take over the screen sharing. And I would like to present this first. Yeah. Yeah, perfect. First of all, I would like to give you a brief introduction about what is the software craftsmanship, right? Yeah, kind of difficult word to pronounce, but yeah. So what is it actually? And if you look at it, there are four key points in this particular uh, picture. So this is from manifesto.softwarecraftsmanship.org, right? So we don't want to create simply a software. Anybody can create a software nowadays. And I'm sure kids in the school also nowadays are learning all the programming languages as early as sixth grade. I don't know, sixth grade or seventh grade these days. People learn computer science and they learn programming, right? I don't know, Java, Python. So these are the languages they are also learning. And now, how do you really differentiate yourself from the others is only by following these four principles, right? So now remember these 4 points, and you can sign this manifesto also. So there is a sign the manifesto that you will really follow these four principles when you become a software engineer. uh, that is mainly the first point, not only working software but also well crafted software. So here we really talk about well crafted. It's just not working software. You can, in one day you can learn something and you can immediately go and create something and it works. But does it really does it really work for a long term? Does it really work in all the situations? Does it work for high number of users? So there are many aspects of working software. We call that as well crafted software. Just like how uh, artists really care for their, maybe you're a painter or whatever the artist you are. um, so basically crafting is the key word here, well crafted software. Second is not only responding to change, but also steadily adding value. So here the keyword is value. Yeah. So what value you bring to your end users, right? When you develop a software, what value you are adding? You should be steadily adding value uh, to their life, right? So they are using your software for a reason. All of us nowadays we use our mobile phones, right? So, and what is your experience of using such mobile phones and apps and everything? And if you don't see a value in it, will you use it? Probably not. You won't use. So steadily adding value, right? So that's another important point. And not only individuals and interactions, but also a community of professionals. And you are professional and you should act like a professional in software engineering world. So community of professionals, we should aim to be a, what, the meaning of professional, right? So you say that he's a professional actor, he's a professional player. So that the adjective professional here really distinguish, really differentiate that person from the others. So we have to aim for being a professional and also a community of professional. Here the word community is because we work in a team in software world. So there is one single person cannot do any almost cannot do any major development. So you have to work with community of like-minded professionals. So how to work along with others, right? That community aspect is very important. And then the last one is not only customer collaboration, but also productive partnership. Okay, so here we talk about partnership with the customers and really understand what the customers really need. Yeah, so the need from customers, you have to really understand when you solve any problem in the real world with your software, right? So we are solving software engineers. What do we do? So we solve real life problems with solutions, right? You can take an example of anything, right? So simply a ticket booking system or movie ticket booking system or anything, or food ordering system, any any software you take, and without customer collaboration, you can't really create an impactful product out of it. So here we call it as productive partnership. So when you want to become such a software craftsman, so keep in mind these 4 points, right? Well crafted software, you should be steadily adding value, community of professionals, and productive partnership. So these 4 points are from the software craftsmanship um, that will help you when you become software engineers, right? I'll share this link in the chat, or you can also quickly find out software craftsmanship manifesto, right? Enough of that. I don't want to bother you with a lot of theories, so I want to also give as much as some practical tips. How can you write really better software, right? What are some of the coding principles? And some of you have learned some of the programming languages, maybe Java or Python or JavaScript. It can be any programming language. And what are the coding principles? I'll give you some important key points. In fact, this is what our company employees are also learning, right? So when they code, they have to write a clean code. They have to write a better code. So I'm going to share the same knowledge with you all. Uh, for that, let me go to another presentation. Uh, yeah. Yeah. So let us go. I hope you can see this presentation now. Yeah. So I'm going to talk about clean coding principles. That is definitely the one that we want to talk about in software craftsmanship. So to write clean code, right? So whenever you code, you always think, is it a clean code? So what is the meaning of clean code? I'll come to it very shortly. Um, why clean code matters? If you ask why clean code matters, people spend a lot of time reading the code than writing the code. Think about this. We are all software engineers. We are paid. When you join a company, you are paid to write software. But ironically, you spend far more time in reading the code. Um, so why are we reading the code? Whereas we are supposed to write the code, right? So why are we reading the code? It's simply because it's not only you are writing the code, it's a team effort. Everybody is writing the code in a team of 10 people, let's say. Everybody else also writing code, and you have to collaborate along with them, together with them. So you have to read the code most of the times. You can go with this 80-20 principle, right? 80% of the time you spend reading and 20% time writing. Yeah. So reading time is far more than writing. Okay. So then if you have to read a code, do you prefer to read a clean code or an or I would say dirty code? Yeah. So which code you would like to read, and which one you can read easily, right? No, it's like handwriting. If you have a good handwriting, you like to read, right? And if the handwriting is poor, can you read? If you have a letter, nowadays nobody writes a letter, but yeah, emails, SMS and WhatsApp and everything. But back in those days, we write a lot of letters, right? So when the handwriting is poor, we don't like to read. We cannot understand anything. Very simple, very similar to that in software engineering as well. The code can be clean or it can be dirty as well, just like handwriting. And more time we spend in reading, and if you cannot understand, if you cannot read, what will you interpret out of that, and how can you contribute to that particular code base? So reading time is more important. Reading is important, and understanding the code is important, and only clean code can be maintained in the long run. Otherwise your productivity takes time, to understand the code. You have to read again and again and again to understand. So the productivity takes a plunge as the code quality is not great. Now we talk about the grand redesign in the sky. So that means completely rewrite everything. If you have created a software, and if you cannot understand something, you try to create one more, right? So try to do everything on your own. So that is also not a good practice. So the grand redesign in the sky are often doomed. To say that it's also not a good strategy. So the only way is to have clean code, understandable code, which is also testable code. Okay, clean code is also testable code. And writing clean code, again, I bring this point of professionalism. It's a matter of professionalism. So of course now we use AI copilots, right? So chat gpts and copilots, and they also generate code, right? And do they generate clean code? Do they generate proper correct code? Sometimes not. Okay, why they don't generate good code? Sometimes you hear about this hallucination, right? I mean, this word became very popular now with the AI, because the AI hallucinates, and it can imagine things, it can generate something, and may not be completely correct. Okay, and also it is based on what data that AI has been trained on. So if the data that we used to train the AI is not good, you will also get poor. I'm sure you know very well about this. So clean code is also important for AI to generate. So if the training data is not clean, the coding suggestions will also be bad. Okay, so that is something like I want to give you an inspiration why we should write clean code. Um, and I will just give you a few definitions, and I'm sure you know the first person in this list. He is the inventor of C++. Beyond, he says clean code does one thing well. It's a very simple definition, and there are many clean code, uh, you know, definition. And I like the one here. Clean code always looks like it was written by someone who cares. Okay, so when you care someone, you how do you take care of them, right? So really is exactly something like that. The clean code, when you write, if you really care for that, you will write a clean code, obviously. And clean code, again, this is very similar meaning that I said. Clean code can be read, enhanced by a developer other than its original author. Yeah, anyone can read easily. Clean code reads like a well-written prose, and code never lies, comments sometimes do. We also don't agree with the professional developers. They don't agree with a lot of comments in their source code, because the code should be talking, and you don't have to write comments. So that's something debatable for many people. But code never lies, because sometimes comments can be outdated, and the code is always the source of truth. Okay, so basically these are all the clean code definitions, and this is taken from the book called Clean Code. I will talk about this book very quickly at the end. If you are interested to know more about this coding principles, if you're interested, if you can get this book, please go ahead and read Clean Code by Robert C. Martin. I will quickly go through some of the clean code principles and give you some example code which you can understand. Um, the basic clean code principles, there are three, and there are more principles, but the basic one is: do not repeat yourself, keep it simple, stupid, and you ain't gonna need it. Have you heard about these principles? Do you know all of them? And when you start to learn any programming language, keep these clean code principles in mind. Learning the language without these principles does not help. It helped to some extent, but it does not help you to become a professional developers, professional software engineers. So these three clean code principle, you can remember the acronyms: dry, kiss, yagni. So these very simple ones, like don't repeat yourself. What does that mean? Don't repeat yourself. uh, when you write code, sometimes you write a piece of code and repeat that in many places. Hmm? So the problem with that is the code is duplicated in many places, and it can create problems later when you have to maintain it. You need to, if you change one place, you have to change in all the places, right? You have to create a kind of a reusable component, reusable code, so you don't repeat the code, same code again and again. So that is basically the first point: don't repeat yourself. The second one is keep it simple, stupid. That means for any problem that you're trying to solve in your software, you as simple as possible, right? Most simplistic approach you should take, and keep it as stupid as possible. Also, no, the word is stupid, simple and stupid, and try to keep it as simple as possible and add only complexity as needed. Don't try to think too much in an over complicated manner, and that is unnecessary for most of the problems. Of course, some problems are complex and you need to really think hard, but most of the real world problems are actually simple, and you can really keep it simple, right? In this case, don't have to complicate it. So that is the second principle. And the third one is you ain't gonna need it. That means, if when you are writing code, you have to really only look at what is the current problem that you are trying to solve, and don't try to add unnecessary code into your software. Don't think, okay, today I don't need it, but tomorrow I might need this. Suppose customer comes to you and saying that I want this, you only write code for what really customer wants, and don't think, okay, tomorrow customer might come and ask for another feature and I want to write the code right now. That is not the clean code. You don't have to write the code and predict the future, and I want something in the future that I want to write now itself. No, don't do that. You ain't gonna need it. Simply delete them, or simply don't write them. Okay, so basically these are the basic clean code, very easy to understand, very simple concepts, but that is fundamental code, clean code principles. Don't repeat yourself, don't repeat the code again and again. Keep the simple um, keep the simple logic, and don't complicate them. And if you don't need the code, don't have it. So these are the three basic principles. Feel free to search for more, and I'm sure you will find a lot of examples uh, talking about these three clean code principles. Moving ahead, um, I will give you a few examples, and maybe you can comment in the chat what is more meaningful in this. So I talked about readability. Code should be readable, and in that case, I say use meaningful names. And if you create a simple program and you will say int d int, if you want to keep some kind of days, and I see a lot of you saying int days. Second option is what you prefer. um, Okay, I see one person says third option. Yeah. So a lot of you say second option. Nobody is taking the first one in D. Some of you taking in D. Um, yeah. Actually, third one is the right one. Yeah. So int elapsed time in days. Why? Because if you simply give variable name like int days, and if you let's say 2 or 3 or 4, whatever the value, what does it really signify? Is it, what days is it? Is it number of days in a week, or number of working days, and what is it really? So you don't understand that. Then someone has to write the comment. Okay, so this days really mean this. is not necessary, right? So if you look at it, you can keep a meaningful name, elapsed time in days. So very, very meaningful, very clear kind of a variable we declare. So go for the third one here. So readability is key. Question each and everything. So what is really when you write a code, think someone else. Can the other person understand this without asking me anything? You should not ask the author of the code every time. What does this mean? What does this mean? No. So you should not make them do that. So try to put yourself, when you are writing the code, try to put yourself in the shoes of a reader, and every line, if the reader will understand or not, right? Readability is key. So again, remember that reading time is more than writing time. Okay. So okay, then moving on to the next one. So why that option is important? Again, the name itself, elapsed time in days, that itself very clearly saying so what that really number means. So if you have a variable like elapsed time in days equals 10. Okay, now by looking at this, immediately anyone who reads the code can say, okay, the meaning of 10 is how much days elapsed since the expiry date, maybe the product expiry date or whatever, and since that date how many days are elapsed. Okay, so if you have a meaningful name like this, then you can associate a better meaning to the value 10. Okay, 10 really means elapsed time in days. But whereas if you put days equals 10. Okay, days equals 10, what does it mean? What day is it? You don't get the meaning. So have a meaningful name every time when you declare a variable. Even for your college projects, if you create a simple program, always think if this is a clear name or not. Same way, class name and method names, right? So you write classes, right? You create classes, you create objects, and then you write methods. And have you thought about what's the naming convention for them? Hmm? So the naming convention is like class names should be nouns. The class names, like in this example, location type validator. Validator, it's a noun. Okay, class name should always be a noun, and method name should be a verb. Like in this case, validate address is the method name, get address is the method name or a function name, and it has to be a verb, starting with a verb, validate, get. So these are the verbs, whereas the class name should be a noun. So always keep this in mind when you write a class name. Of course, if you're writing code in Java, you create a class, and there are many object oriented programming languages out there like C++. So you start thinking about a class name, right? And then when you create a class name, don't give any name just like that. Think about it. Is it a proper name? Is it a proper noun that you're creating? And then when you're writing methods inside the class, think it is a verb, right? Should start with a verb like validate or get or format or print or save. There are such verbs available that you can use. Okay, that's about the class names and method name convention. Now I talk about something interesting, that is noise words, right? So what are these noise words? No, you haven't maybe heard you haven't heard about these noise words in software programming. So what is noise words here? Can you guess what can be the difference between the four different customer data, customer object, customer info? If I give you this four different words or four different terms, can you tell me the difference between the four? What is customer data and what is customer object and what is customer info? By giving simply the names, can you tell, okay, data means, customer data means this. It could be customer name, address, and customer object, maybe it's, I don't know, customer location. I don't know. Can you really say, can you differentiate between the data, object, info? right? So we call them as noise words. Okay, the only meaningful name word here is customer. Yeah, so the only meaningful word here is customer. So that means you should not have any noise words in your class names or object names or whatever, and that is simply a waste. And there are more noise words like util, manager, processor, helper. Yeah, so you can guess, a lot of comments I see, this could be that, it could be this, right? It could mean so many meanings, right? And there are ambiguities here. It's never a clear definition. Okay, what is info? What is object? What is data? So, there can be literal meaning of all this in English, but when it comes to programming and using these words, always cause confusion. Okay, so better to avoid these words. They are only adding noise. Okay, further noise words, again, processor. What processor is it? Is it a microprocessor or what? So in software programming, and we use these words knowingly or unknowingly, but these words are simply noise words, and we should be using as minimal as possible, right? So again, noise words are confusing when you read the code, so don't use them. Moving on, the next concept. Yeah, so all of these concepts that I'm not that I'm talking about, it's not I came up with. It's all part of well-known clean code practices. Okay, so part of the clean code book. So if you read the book, you will know more about it. Now, this concept, pick one word per concept. Which one do you choose? Fetch, retrieve, get. You can guess which one you should be using it. All of you say get or fetch. Fetch. It depends on the context. You can use any of these: fetch, retrieve, get. um, let's say you all of you know about database, right? Database stores records, and you applications can query database and get some data out of it, and that is one possible use case. And then you have a file system, you have files, and you get some data from files. Where else you can get data from? You can get in data from direct user input. Yeah, users can also type in the data, and you can also get the data through the users directly, right? So there are different use cases, different ways of getting data. Now, pick one word per concept. Means you can use any of the words, but pick one word and use it consistently in your program. So if you use get for getting the inputs from users, then use the word get consistently. Don't mix the words. Okay, one time you use get, another time you say retrieve, another time you say fetch for the same concept. Yeah, don't no mix the words for the same concept. If you, for database reading, you can say retrieve from database, then constantly say the same thing every time: retrieve from database. Fetch from a file. Yeah, you want to fetch data from file, so use fetch from file, then use that word consistently. Okay, so pick one word per concept and use that word consistently. Don't mix words uh, in your program. All right. Okay, so that is good. Let us move on to the next one. I think, yeah. Okay, this one. Names should be pronounceable. Pronounceable. What is it? So when you create a class, I told you the class should be noun. It should be pronounceable, and you have to talk about the code about at times to others, right? You need to explain the code. And when you name it like OCMTX, uh, I can guess what is the TX transaction, maybe, or OCM. I don't have any clue what OCM means. right? So don't give such acronyms in your code. You might even forget. If you give this name after many years, you might also forget what does that mean. So you will have to write some comments which are not necessary. So you have to really give a meaningful name. Okay, so that's about this particular concept. Don't give this such acronyms, short abbreviations in your class names. And names should be searchable. And I think this is very common mistake we often do. Okay, and what do we do in this case? What is the right way to have numbers like this? Case 7, switch case. If you give I, switch I, and case 7, what is the problem with this? Good luck searching for I or 7 in a bigger scope. Means if you have a big class having hundreds of lines of code, and you write switch 7, and you simply search in your control F, and you put this number I, or letter I or 7, and maybe there are too many entries. Yeah, so in a loop you normally use this kind of switch case, right? So the best practice is to have constants for these number 7. Yeah, you're not, I mean, both are bad. Now, having I or having 7 is definitely not a good idea, right? So the best is to have meaningful word. Again, I should not be there. It should be meaningful variable, like we saw earlier with the day, d, and so on. So the better way would be not to have I, because in switch also there is an I. You see, yeah, it'll unnecessarily, you will be searching too many entries. and and um, and constant 7, you should not have such number 7. You should have a constant declaring that number, and then you have it in one place. Tomorrow you want to change the number to 8, you can change in one place, right? So this is not a good way of putting the I and 7, so should be avoided. Okay, so now we are coming to a more advanced clean code practices. Is the code familiar to you? Can you understand what this code is doing? Simple yes or no would be sufficient. If you are able to understand this, okay. Anyone, which programming language is this? Okay, some yes, some no. So this programming language is Java. Okay, good. So you are able to recognize it. Nice. This law of Demeter, okay, law of Demeter is actually says each unit should only talk to its friends, don't talk to strangers. Okay, don't talk to strangers, talk to only your friends. Okay, what does it mean? If you see the code, dog has a method called getHead, and it's a method called getMouth, and the mouth will bark, right? So now, what's wrong in this? Why is it okay? Why is it wrong? So there is a red color background, so you know what is the right approach and what is the wrong approach. So this one is definitely not a clean code. So the first one is not a clean code. The second one is a clean code. Whereas I have public class dog, a class, a noun, and method bark is a verb. You have public void bark. Now the bark method is doing get head, get mouth, bark. And anyone who wants this functionality, they will ask dog dot bark. Now the difference to the previous one, in dog, there was no bark method. The bark method was inside the mouth. So I need to get the head first, then I need to get the mouth, then bark. You know, you're going inside dog head and then going to the mouth and then asking the mouth to bark, please bark. So now the second approach is more cleaner way, right? Right? Do you agree? Which one is better, the first one or the second one? Second one, yeah, you agree? So what about the first one? Why is it not a good one? Any thoughts? The first one, if you have the answer, you can try. You can type something in the chat. If you have any ideas, I will tell you. The approach with the first one is basically you are talking to strangers. Your friend, who is your friend in this case? Dog. Dog is your friend, and you have to know, okay, you have to remember many things, cause confusion, understandable. Yeah. So the readability is one thing, but it is also not proper, because you are looking at the dog internal structure. Okay, you look at the dog and it has a head and it is returning the head in a get head, and get mouth is returning the mouth. So you need to know a lot of internal knowledge about the dog. Okay, the example is very trivial, and you know that dog has a head and mouth and it barks, but it's not the real life problems are not like this. So this is just to give you an example so that you understand the concept here. The head is an internal details of the dog. Mouth is further internal details of head. And you are digging deep into the internals and finally figuring out there is a bark method, and you ask the dog dot get head, get mouth, bark. And tomorrow, if the internal structure changes, okay, tomorrow instead of mouth, nose barks. It doesn't. But if something else barks, then this complete logic will be wrong. Yeah, because you relied too much on the internal code of dog. Okay, then you are tightly coupled to the internal structure, and if the internal structure of the dog changes, your bark will not work anymore. Okay, so it depends on the tightly coupled with the internal structure. So that's not, from your point of view, that's unnecessary. So the right way would be, dog should only give you a method called bark, and you as a consumer, you can directly ask the dog to bark instead of getting the internal details. But of course, the internal details are known to the dog, and that will ask, okay, now inside the bark, you see get head, get mouth, and bark. And tomorrow, if a dog barks without a mouth and with something else, the internal, it will change, but it remains bark. The method remains bark. I always call bark. I don't care how you bark, right? I don't care your internal structure. I only need the barking. I want the bark functionality, and doesn't matter how you do it. This is what an interface based contract. Doesn't matter how you do it. All I want is functionality, bark. Okay, so that is basically the concept here. Talk to your friends, don't talk to strangers. That is dangerous, right? Okay, that is what we try to say with this example. So encapsulates your internal details and don't expose them to the outside. Okay, so outside they are not interested in internal structure, they only want the functionality. Okay, so I hope this is understandable now. We will move on. So I have a few more such examples. We will quickly go through all of them. So next one is single level of abstraction. This is a bit, I would say, very often people follow this principle uh, because they don't understand it. Yeah. So what is this? Let's try to understand this. Statements within functions should be at same level. I have 3 lines of code, and all of them are at different levels. One is at a high level, next one is intermediate, and low level. Having all these levels mixed in single method, a single method which has all these three lines, there are chances that it confuses people. If you're not confused, fine, but in most of the cases it could be confusing. And what is, first of all, let's understand high level meaning. What high level meaning? Abstraction. What is abstraction, right? So when you say this is an abstract, you submit a paper and you have an abstract. Okay, instead of the whole details, you are giving only the abstract. Yeah, exactly, the important information. So in this case, save is a high level abstraction. You know that this is going to save something. Yeah, it's a high level abstraction, and you don't know the details. Where is it saving? How is it saving? Okay, so all that information is abstract to you, which is high level. Then the next level is intermediate level of code. Any line of code, you can classify them into one of these three. Any line of code you write, it would be low level or intermediate or high level. Okay, intermediate level meaning you will know partial information about what is being done in that line. Email dot is valid. It's an intermediate level. I know that it is checking the email's validity, but I still don't know how it is doing. What are the validation criterias? So what is the validation? Exactly what is it looking for? I don't know, but I know it is validating the email. Okay, so that is intermediate level. The low level is string format, result, percentage s. That is low level string operations, any calculation, arithmetic calculations. So they are low level because there is no ambiguity, there is no confusion by looking at the low level. So any line of code you write would be one of these three levels. And this concept, this principle say that mixing the levels is confusing, and don't try to mix levels all the time. Okay, you are allowed to have one or two levels mixing together, but then not everywhere. That is going to create confusion. So what is the solution to it? How do I avoid this abstraction, right? So if you have a code, you can try to have a high level abstraction like save. How do you convert this second line of code into a high level abstraction? Intermediate level to high level, how do you convert? Okay, meaning I would simply write a line of code saying validate only. Yeah, correct. By valid function only. Yeah, so you just have validate. I would say validate because it has to be a verb. So validate, save, validate. The last one, format. So you can have all of them are high levels. All of them are high levels, and you can, inside the high level function, you can have intermediate level, low level code. So nutshell, line of code can be classified into single level, high level, intermediate level, low level abstraction, and do not mix them. Try to avoid them and try to convert them into a high level, and then inside that function try to have all of them at low level. That would be one way of solving this problem. Yeah, so before I go to the last part, so this one is an expression. I talked about comments. Yeah, so the first one example here is talking about a code with a comment. The second one without a comment. Which one do you prefer? First one or second one? And obviously the answer will be second because the answer is given here. But most of you like the first one, but it's okay. If you like the first one, that's okay. With comments, many of you okay, I understand the sentiment here. We love to read in plain English, right? Check to see if the employee is eligible for full benefits. But we are software engineers, software engineers should like the second one. Right? The first one anyone can read and understand, but the second one only software engineers can understand. No, what is this? Is eligible for full benefits? Oh, it's a method name, and there is a logic inside the method, and that is actually checking for full benefits, right? So it's very much clear with the method name. Okay, so that is why we say that the second one is preferable. You can wrap the if condition into a method and call that with this is eligible for full benefits. Then this comment is redundant. Yeah, so you don't need that. And what do you have in your comment? You have it in your method name. Employee is eligible for full benefits is exactly what you have. Employee is eligible for full benefits in plain English text. Only thing that is missing is check to see. In fact, if is also there. If employee is eligible for full benefits, literally that is what we have in the second one also. Only check to see is missing, right? Now you convert the translation, the comment into a method name which is more clean. Okay, so now finally I want to close the session with quickly looking at these 5 principles. Have you heard about the solid principles? Some of you yes, some of you no. Do you know about this? No. Let's see. Some of you yes. Yeah, no, most of you know. Yeah, yeah. All right, all right. So this is I want to leave today with this principle. And anybody knows object-oriented programming languages? Let's see how many yes, how many no's we have. Object-oriented programming, Java, C++. Okay, I see most of the yes for this question, but no for the solid principles. Absolutely must for anybody who knows object-oriented programming. Um, Go and read this about this solid principles. May not be there in your book. I don't know if your textbook has this, but Google it for solid principles. I will give you a quick 1 minute explanation of all of them, but you need more time to understand this. Solid, yes, stands for single responsibility principle, object open closed principle, and Liskov substitution principle, and interface segregation principle, dependency inversion principle. A lot of principles here. We are talking about clean code principles, and this is the ultimate, I would say, the top solid principle. Of course, the other principle, the basic ones, everybody should know, but this is two advanced principles, I would say. And if you master this principle, and I'm sure you will write clean code. Okay, so that is what we are going to see quickly. Single responsibility principle, the first one. An object should have one and only one reason to change, or another words, an object should be only responsible for only one actor. Okay, what does it really mean? Now looking at the example code here, what do you see here? How many class do we have on the left side code? How many classes we have, right? Employee is one single class, and how many different functionalities we have inside? How many responsibility this employee class has? Two, correct? There is one class but two responsibilities. What are they? Calculating tax and saving employee to the database. So one class, two responsibility. It's against single responsibility principle. Now the solution is very simple. Often the solution is very simple. So we just have to keep it simple and stupid. So we are keeping it simple and stupid here, having two classes to putting the responsibility into two persons, right? Single responsibility, then that person will do the job better than having multiple responsibilities. So in real life, it's possible that you can have multiple responsibilities and do all of them good. But when it comes to software engineering, software programming, we will have to only focus on the single responsibility. Okay. Yeah, looking at the time, we have 5 minutes, so I will quickly cover these 4 more principles, and you can take them home, yeah, for homework to read more about it. Open closed principle. Here on the left side, I have an example with switch case. Yeah, familiar with this switch case? And whereas this right one is called uh, interface inheritance based. You see paid employee and employee paid by R. So here we are really going for polymorphism, object oriented concept, and really make use of the object oriented concept for such switch cases. Okay, so in this case of switch cases, so it is kind of hard for extensions. If you want to extend it, you need to go and modify the switch case, which is again not a good idea to change this again and again. You might have this kind of switch case in 10 different places. Will you go to all the places for modification? That's not a great idea. So you will have to have inheritance with one base class and multiple subclasses. It is easy for extensions. Tomorrow, if there is another use case come, then you can easily have another subclass. Okay, so this is called open closed principle. Open for extension, closed for modification. Okay, Liskov substitution principle. Third one is Liskov. Subtypes must be substitutable for their base types. Here, there is an employee base class, two subclasses. One is good, regular employee. Second one is intern. Interns don't have bonus. In companies like many companies, they don't give bonus for interns. They might give some payout, but not regular bonus payout. So calculating bonus is not allowed for interns. So in this case, you will get a runtime exception. If someone calls on the intern object, calling calculate bonus, you would get runtime exception. It is not allowed. Okay, so this is not following the Liskov substitution principle. You have to modify this inheritance chain to make it a proper inheritance tree. So how are you doing it? The bottom example, employee with benefits, which can get the bonus, and then interns cannot get the bonus. So you have two base classes, one intermediate base class called employee with benefits to having the calculate bonus. Okay, so then this way we make this Liskov substitution principle. Are you getting it? I think this is the one most hardest one. The last two ones are kind of quite simple. This one is especially very simple. An interface should not be having too much of things to do, right? So if you are an employee of any company, and if you look at the responsibilities you get, is it really possible to have all these three responsibilities for an employee? Look at the employee's interface, having managing team, designing a product, develop the code. Literally no employee would do this. Only the super computers can do, but no human beings would be doing this job. But then you will not be doing a good job in all of this of task. So what is the solution to it? Segregate the interfaces. Don't have one interface, have three interfaces. Developer, manager, architect have responsibility. Think about the single responsibility principle here, right? You have three responsibilities on the left side. Yeah, so you should have a single responsibility principle. And in case someone is really having multiple responsibilities, they can go for multiple interface, because classes can implement more than one interfaces, correct? So developer, architect can be implemented in one class. Okay. The last one, dependency inversion principle. Here what I mean is the left one here, employee, you have a dependency to a tax calculator. Do you know, in our country we have multiple tax regimes, old tax and new tax calculation, right? Do you follow this income tax? Though you don't pay income tax, do you know this, right? Every year budget we get something about, we hear about this. So yes, that is called tax calculators. Employees can opt for, I want to follow the new tax regime or I want to follow the old tax regimes, and tax calculators are different. Now, if you have a code like this, you have only one calculator. How do you, based on the employee's choice, how do you take a different tax calculator? For example, I have chosen the new tax calculator regime. For me, calculation is different, and someone in my company will have a different calculation. So the answer to this is invert the dependency. Do not depend on one single implementation, depend on abstraction. What do you mean by abstraction? Again, like an interface, like an abstract class. You should have a abstraction and get the implementation from outside. Based on the employee choice, you select the calculator. So this way you are inverting the dependency and allowing for more flexible uh, implementations. So we come to the end. I know it's been a lot of points, concepts, especially the last solid probably could be a bit overwhelming, and I recommend you to read more about solid. We can have question answer time now. I want to just close with this book recommendation, uh, Clean Code. So Robert C. Martin. Make a note of this. Those who are interested can read about this. It will definitely help you in your software engineering world. Now, time for questions. I have time for questions.
Yeah. Shall I read out for you?
Yeah, please.
So one scholar is asking how to increase the security of software.
How to increase the security of the software. Okay, so I think that's a bigger question. Security of the software. When you write a code, right, so you have to follow, like we discussed now, the clean code principle. There is also a secure coding principle, and definitely you need to keep in mind what kind of hacking is possible in your code. Like, very simple one is injection, right? SQL injection is what we call. uh, SQL injection is something, if you don't encrypt, don't encode the input data, it can lead to a data leak in your database, right? So this is one example I'm giving. So when you write a program, so be aware of all the secure coding principles, and for each and every known security vulnerabilities, we have solution. So you can, if you follow all of these best practices, you can secure your code from the hacking and attacks.
And the next question is regarding the difference between development and operations in the DevOps.
Okay.
Operational department. They want to know about
Yeah.
operational
Yeah,
department.
definitely. Yeah. So the development team is the team responsible for writing code and creating the applications, right? Any product you take. Let me give you an example of the mobile apps, right? You might be using apps like Swiggy, Zomato, all these applications, anything, right? So the team that is doing the development, writing the code, is mainly responsible for that's called developer's job. And the other hand, you have operations team that takes the output of the development team, and then making sure that this code is deployed into a cloud infrastructure, cloud platform. You can say there are a lot of cloud platform. SAP has our own platform called BTP. And many other companies have their own platforms like Microsoft, Amazon, AWS, and Google Cloud Platform, and they deploy on the cloud platform and make sure that customers can access them, and make sure that the app is always running. And when suddenly, if hundreds and thousands of people access an application, what happens to that? Yeah, it might crash suddenly. The job of operation team is to take care of the scalability. The application should scale for higher load, higher demand. Yeah, so that is primary responsibility of operations. So the development team responsible to write code and make sure that the business problem is addressed, and the operation team really takes care of application is running 24/7 without issues. So that is shortly the operations team responsibility.
The next question is regarding according to single responsibility for every method, we need to create a new class.
For not for every method, you don't have to create a new class for every method. You could have in a single class, you could have multiple methods. In the example that I showed, it had only two methods. They are completely different. Employee tax calculation and employee save the employee. So these are two methods. So I showed two classes, but does not mean that that classes will have one method each. Yeah. So anything related to tax calculation, it can be like 10 methods. All of them are related to tax calculation. Okay, they can go together in one single class. And anything related to saving the data employee to database can go into that second class, right? So you have to look from the domain point of view. Is it completely two different domain? If so, then have different classes, but not like one method for one class. That is not a good way to understand it. So you could have one class with multiple methods, but cohesiveness, you understand what is cohesiveness, right? So if one method is cohesive to another method, means they are tightly related to each other, then they can all be together in one single class. If the methods are not cohesive, then they should not be in one single class, then you separate them. Okay, so that should be the right point of, right way to look at it. If the methods are related to each other, then keep it together. If they are not, then separate them.
And the next question is which language is better to learn, C++ or Java? And also the question was related to C also.
Yeah, so language, with regards to language, I would say all the languages are really good, and I wouldn't favor one language over the other, and you never know which product, which company you will be working for, and you should be open to learn any language, and and you should be strong with the conceptual understanding. That's in programming, that is important, and learn that before learning the syntax of the language. And once you learn the algorithm of data structure and algorithm, I'm sure you know about that, and that is important than language. And the logic, think critically, logically think about the problem, and language is secondary, and you can learn any language in let's say 7 days or 10 days or 30 days. That's not a big deal. Today you work in C++, and tomorrow you have to go to Java, and you can learn in 1 week. That's not a big problem. And the right mindset and right understanding of programming is important, and clean code practices, these are all independent of programming language, what we talked about today. So any programming language, these concepts apply, right? So you can learn any language. Whatever opportunity you are getting now, learn that language very well, thoroughly learn, and you can easily convert or learn another language very quickly.
And the next question is it important for a software developer to learn cybersecurity?
Right, yes. Everybody should be knowing the fundamentals of security. Even if you might not be expert in security, and not everybody needs to be an expert in security. Um, in every company, there are few security experts, but there are many developers, right? Let me give you a rough number here. If you find 100 developers, maybe there are 10 security experts, yeah, or even lesser than that. So in a company, number of security experts are much lesser than software developers. And every developer should know basics of security, cyber security. And you don't have to be too much of expert into that area, unless you want to become a cyber security expert. That's a different job role. But every developer should know the basics of security, should be able to write a secure programming, secure code. That much everybody should be knowing it. Yeah.
And the next question is what are the software skills we need to have to excel in our journey as a software engineer?
What are the software skills? Software skills, I would say, um, for software engineering, of course, you should be very strong in one programming language. So take one programming language and be very strong at it. Doesn't matter which programming language it is, like Java, C, C++, Python, Node.js. There are Ruby, Rust, Golang. So there are plenty of programming language out there. Choose one and get better at it. If possible, take certifications. I don't know how many of you know about certifications. There are a lot of certifications available for different programming language. You can really go into the deep of that programming language and learn. So that is one thing I would say. And then software, any database, you can also take database as one of the next to programming language. Give importance to database knowledge. Um, so any database, like you have SAP has our own HANA database, Oracle, Microsoft, all of them has SQL. So knowledge of SQL is important. Okay, structured query language, and learn a little bit about the user interface technologies. So there are plenty of UI technologies available there. So I talked about programming language like Java, C++, Python, and the backend, the database, and then the front end UI. So this gives you end-to-end application development knowledge. And then you can add a little bit of security skills, right? You ask the question security. So this will give you a complete knowledge about the software. And yeah.
And one scholar is asking, what is the best language for DSA?
For the ECE,
DSA.
BSc,
D for dog.
Oh, DSc. What do you mean by DSc? I didn't understand.
I think DSA and Java.
DSA. Okay.
There is a concept of DSA and Java. Maybe scholar is asking regarding that.
Okay. Data
Ah,
science? Is it something to do with the data science, or I don't know?
and okay, we can take another
Oh,
one.
okay. Data structure and algorithm. Okay.
Yeah.
Okay. Yeah, got it now. Data structure and algorithm. Yeah,
Mm.
okay. So data structure and algorithm, I would say really go for C. So you understand the structure and algorithm, because C is mostly the first language that you would learn probably is C, and have good understanding of C's data structure and algorithm, the way how it interacts with memories and pointers and concepts like that. So that will be the foundation. That should be the foundation for any other programming language. And then definitely you can choose Java. I would just give three programming languages here, most often used in the enterprises, in the companies. So Java, JavaScript, Node.js. Node.js and Python is also very powerful. So these are the three major programming languages out there in the enterprise world. Learn any one you learn. No, you cannot learn all three of them. So learn one of the language, Java, Node, Python, any one language, and learn something about database, SQL, and something about UI. So that would be sufficient for software engineers to begin with, at least to start your career. Yeah.
Then one last question. How can we manage programming with machine learning if anyone wants to learn?
Yeah. So the machine learning, of course, now is a very trending topic, right? The AI and machine learning. The basics for machine learning is your data structure and algorithm. Yeah, the data structure and algorithm is the foundation for everything. Either it's a programming or database or machine learning. Have your thorough understanding of algorithms. I think now in your course you might have something like search algorithm, sorting algorithm, so these kind of things, right? So uh, have a good understanding of that. And machine learning is all about data also, right? Have the understanding about statistics. I don't know if you learn about the statistics and all in your course, but have probabilities, probability theories, statistics, these kind of additional subjects you will have to learn when you want to become AI data scientist or a machine learning expert. But I think you should not be too much worried about that right now, because you will have time later on. Nobody is expecting you to have an expertise in data science and machine learning AI at the beginning of your career. So really, the foundation should be very strong. The concepts of operating systems. Yeah, I missed that point. Operating system, how Linux kernels or operating systems work, and how virtual machines work. Some of the fundamental computer science topics should not be overlooked in the all. So we can get distracted with all the new trending terminologies. But the foundation is the for computers is operating systems, and the programming languages, and the databases, and the user interfaces, and how to secure them all. So these fundamentals should be more focused. Once you get good understanding of this, and then you can pick up the machine learning, so on. Yeah.
So if you are okay, we have a few more
We can
questions.
go on. Yeah.
Okay, then that is great. So the scholars are asking regarding the best platform for coding.
Which platforms are best for coding? um Platforms, I don't know if what you mean by platform. Is it you're talking about the integrated development environments, the IDEs where you are coding? uh, so for example, you're talking about the tools for coding, like.
Yeah, it could be tools.
Yeah, so you could use, there are a lot of tools out there, like Visual Studio Code. I don't know if you know about that, VS Code, yeah, and IntelliJ, JetBeans IntelliJ, or Eclipse. So these are some of the IDEs you can use for coding, and you can choose any of them. Yeah, so based on, for Java, you can use IntelliJ. For C++, VS Code. Python also VS Code. Node.js VS Code. So VS Code can be used for any programming languages. So use that. Also online platforms that are out there, right? So you don't need to download and keep it in your laptop. You can go to browsers, you can write code. Nowadays there is a browser based IDEs are available, so you can go and do that. So there'll be a lot of such. Yeah, I think some of your colleagues are putting. Yeah, so you can use all of these platforms. Yeah.
Almost we are done with the question, and there is one question the scholar was asking. They want a roadmap to start the coding.
Yeah, to start coding. Right. So you can find a lot of online materials, or you have books, right? So use any of them, and start from really the basics of coding. Simple. The data types of coding. Integer. Understand everything about the data types, starting from the data types, and then advanced operators, the if conditions, for loops. So these are the main constructs of your program. You could write any advanced applications, but fundamentally you are going to write simple statements, simple operations. So start from the beginnings, start from the basics, and then as the chapter wise, when you proceed, so you would be getting a lot of knowledge. And that's how you should keep your progress, and start from the basics. And yeah, any language you take, like Java or C, C++, Python, you can take any language, and with the help of a book, a good book, or any online resources, you can take the help from.
And there is one question, sir, how we can make Java language to easier to understand?
You should practice. Yeah, practice will make you better, and like everything. So try to have in your, if you have time, you spend some time every day or a week, and try to write a simple Java programs, and try to understand the. Maybe you can watch a lot of. I think nowadays a lot of online resources available. You can read, you can watch videos, and then try to practice simple problems, solve them with the program. No, you can build like a simple example, like calculator. How do you build a calculator in a Java? Very simple: addition, subtraction, and division, multiplication, right? Just write a simple Java program, or whatever language you choose. Solve small problems to start with. Familiar with the syntax, step by step, slowly, and then take next level. take a little bit more complex problems and try to solve it. How do you search a given number in the list of 10 numbers? How do you sort a list of numbers? So take a bit more, step by step complex examples. So that is the way I would say it's you should learn any programming language. Don't just read or look at the resources, but practice hands on. Try to code yourself. uh, Remember the syntax. So that's how you should start coding.
Okay, we are
Banupriya,
almost done with.
Banupriya, this is Sheetala from SAP. Hi, Tanir.
Hi,
Hello.
Sitala.
Hi.
Hey, Sidhana.
I think there's one question that's pertinent, whether I don't know whether it's answered, about the jobs and internship in AI ML domain. There's a question on the chat here.
Okay, jobs. Yeah, okay. I didn't read, but yeah, just to interns, right? I think it depends. If the organization is hiring interns, I think the interns fellow position will be. I don't know if you're specifically about SAP or any company in general. Um, but yeah, so depends on the organizations. If they are going to hire you as an intern, yeah, then yeah, you can go for it. But yeah, what skills you should have, like I said already, computer science basics should be very, very thorough, very strong. The concepts of the data structure and algorithm, the operating systems, and the database knowledge, and some programming skills. And this should be there, and the mindset, like the statistics mindset, data mindset. So these are the things that you need to go into this AI machine language area.
And scholars regarding any internship opportunities, if we come up with any opportunities, we'll definitely update you. Maybe
Mhm,
from SAP or any other organizations. Okay.
mhm. That's good.
Yeah, and I think almost we are done with the Q&A. And thank you so much, Mr. Paniselvam, for sharing valuable and expertise with us today. And the session regarding coding principles was truly enlightening and has given our scholars understanding of importance of writing a clean code. That was very important. Thank you so much. And we would like to thank SAP team and also FFE team for the support.